today antenna is used everywhere. Today is the world of wireless communication. And once antennas are made, we need to maintain them also, so that antenna performance will also not degrade with time, and also it will remain protected with environmental factors like temperature, humidity, rain, dust, everything. Radome is basically made of two words, radar dome basically. So it actually protects the antenna with any environmental factors. It should be electromagnetically transparent. Ideally it should be 100% transparent, but practically it is not possible. There are many kind of radomes available. One is monolithic radome that generally we use in aircraft. But when we are talking about ground-based radome, here our constraint is it should be as broadband as possible. So for broadbanding, we are using sandwich kind of radome. Core is sandwiched between two skin layers. So skin is basically very lossy material. So we try to keep it as thin as possible, while the core is the main parameter which we are trying to design. The geometry of the core is like honeycomb. So basically that. Now the advantage of honeycomb is it is lightweight, structurally it is very firm, and it will provide you the broadband also. Actually in physical testing it's not always possible to have all conditions, means you cannot have all kind of thickness available with you. Suppose vendor is giving you around 10 mm sheet or 15 mm sheet, you will not have a result for 11, 12, 13 or in between. In radome designing, one of the most critical parameter is the thickness optimization and sometimes the geometrical optimization also, especially in the case of honeycomb, what is the edges and all. So in simulation actually you can try to explore even new thing which has not happened till now. So you can actually create the environment, you can excite it, you can model it, you can give proper boundary condition, frequency or whatever is there, and you can simulate it. So you can actually create new theories, new structure, anything. In simulation there is no boundary. The CST, this software, it is so user friendly. Means you do not have to think where is the option to select boundary condition. It is under this tab it is there. First thing is this. Second, we can customize it actually according to our requirement. Third, this is hybrid solver, now it is coming up. So we can use the antenna simulation or aircraft or whatever. We can club two solvers together. We can actually use another thermodynamics also there. There are so many, so much freedom I could not find in any other software. I am quite confident that in CST we are getting quite accurate result because I have measured it experimentally also. I have seen it is nearly matching in all the cases.